Hello and welcome to our pre-recorded workshop on resilience in the connected world, held on 20th January this year. I'm Gunny Dhadyalla, the AESIN Network Director, and I'm thrilled to have you join us. As our transport systems become increasingly interconnected and reliant on advanced technologies, ensuring their resilience is more critical than ever. In this workshop, we explored the challenges and opportunities in building resilient and secure transport networks that can withstand and recover from disruptions. And you'll hear from industry experts delve deep into the state of the art and discuss practical strategies for enhancing the resilience of our transport systems. And so whether you're a policymaker, an engineer, a researcher, or industry professional, this workshop is designed to provide you with valuable insights and actionable takeaways. But before we dive in, I'd like to take this opportunity to invite you to our upcoming conference titled The Future is Electronic: From AI to Power, be held on the 19th of June at the British Motor Museum. And the conference this year aims to bring together industry experts, innovators, leaders, and policymakers to discuss the latest advancements and future trends in automotive electronics and software. Register now to secure your spot and don't miss the chance to network, to learn, and to collaborate with the best in the industry. Thank you for joining us today, and let's get started with the workshop video. Thank you.
So this is Gunny's slide. He's going to talk about a bit about AESIN. If you know who AESIN are, this is your chance to learn. Okay, Gunny.
Thanks, Pete. So welcome again. AESIN is the Automotive Electronic Systems Innovation Network, if you don't know already. We've been around for about 12 years and primarily set up to be the voice of the industry for the electronics and software systems world. We're part of a larger organization. The registered company is called TechWorks Hub Limited, and we cover everything to do with deep tech, from semiconductors, semiconductor design, manufacturing. Something I didn't know, we have over 25 semi-fabs in the UK. So, we represent them with the design community, and also in the Internet of Things Security Foundation, which looks at all things security for the IoT world. Within AESIN itself, we've been monitoring what's been happening in the industry, and I guess over the last half a century, as electronics have evolved in automotive systems, we've seen, certainly at the start in the early 80s, the UK having a prominent position in the development of electronic systems, from early communications technologies to chip technologies. But as time's rolled on, there's definitely been a transition where a lot of the industries, certainly the tech bit, the electronics and software systems industries, shifted out. A lot of it's gone, as we know, to Germany, the USA, and now the Far East, with Japan, South Korea. But as that's evolved, there's been a huge challenge in managing electronics and software. We've heard it over the past few years, incidents related to the Tesla unintended acceleration. We've heard the VW Dieselgate scandal, the chip shortage thing that the industry went through during the pandemic. So it's a hugely challenging industry, and a lot of impact to all of us as we work in this industry. So AESIN's main role is to address the UK position on this and to understand what we can do. And for sure, there's big conversations going on around actually what is our strategic direction, where are we going with the UK, what do we need to do to be relevant and competitive. And we, the AESIN and the AESIN community, I'm just sort of the the facilitator of it all, the director of it all. But to be honest, if the community comes together and gives direction to decision makers and to those that can influence, the special interest groups, I call these the heartbeat of the AESIN activity, because this is really where discussions like this happen. This is where we can really articulate what we think the industry needs. And it's only through the expert opinion and gathering your views that we can start to influence where some of that future intervention might be directed. At the moment, we have 6 interest groups. One of those, actually, the UX UI is transitioning out, and we're actually introducing the power electronics and control systems SIG. But all 6 of these are led by prominent industry and academic experts. The sensors group is led by WMG, the systems group with Pete and Richard, with a huge history of working in the systems world and the infrastructure world. Software-defined vehicle, which is a huge topic in itself, and really very, very topical in terms of understanding how connectivity will roll out future features. Security and resilience. So we've got Paul on the call. Paul is jointly hosting this workshop with Pete and Richard. Paul Wooderson from Hariba Myra. So Paul leads the security and resilience SIG, and again there's some fascinating new topics that are arising around resilience that we will touch on today as well. And the research and innovation SIG I mentioned is led by Professor Siraj Sheikh from Swansea, and it's really our effort to get more of the academic world engaged with what we're doing, because without that foresight and looking into what's happening for the future, we won't be able to bring companies through that can then go and compete globally.
Brilliant.
And I'll just mention, I guess, quickly just the cadence of meetings. So we have a regular, our SIG chairs meet regularly. We have a monthly meeting with the SIG chairs to plan what we're doing in the future. We also have core SIG meetings. So we have AESIN members. So if you're a member, you can join our core SIG meetings that are then working at the next level to define the activities for the SIG and what needs to be done, and what are the meaningful outcomes that we need to produce to start to sway opinion. We have AESIN member SIG meetings. These are roughly 2 to 3 months in frequency, where we invite all members to join and discuss matters around each of the SIGs. And then the final type of meeting is this type of meeting, which is an open workshop, an open event, where we invite the whole of the community related to the SIG to come and talk about pertinent topics. And again, the idea is that, we bring some useful outcome insights from these events that we can then share with other stakeholders. So there's much more I can share. I guess the only other things which I'll mention at the end again is the AESIN conference, which is a key event, and you're all invited. I see there's well over 40 people here, so you're all invited to join. And I will share the slide and the QR code at the end of the session today. So with that, Pete, thanks very much for that, and hopefully we've set the scene for.
That's great. Next slide is on Paul, who's going to give a very quick, or as long as he likes, really, on the security and resilience SIG, about what they're currently looking at and what they're currently trying to do. So over to you, Paul.
Yeah, thanks, Pete. I'll just keep this brief because I'll be talking again later. But Gunny, as Gunny mentioned, I chair the security and resilience SIG, which has been going for quite a few years now. Back in November, we had a very successful and well-attended workshop at Tales in South Wales, where we discussed topics of interest to continue exploring in 2025. Here's a sample of some of those topics that came up around topics like memory safety, how to scale up vulnerability management, the systems of systems topic that is very much the subject of today's joint workshop, the EV charging ecosystem being one of those sort of systems of systems that we're interested in, topics around improving verification and validation for security and resilience, and also some interest in the area of key management. So we're in the process of focusing in on some of the some of the most critical topics for this year. So watch out for kind of future security and resilience meetings where we'll be getting into some of those. Back to you, Pete.
Okay, this is I'll hand this one over to Richard, who's going to talk about the System SIG activities. Hi, Richard, you there?
Yeah. Hi, Pete. Thanks for that. So, morning, everybody. So, I'm Richard Scofield, and I co-chair the System SIG with Pete. And just wanted to just cover the work that's going on in the SIG at the moment, and and the direction we're going through these webinars and workshop events. So a backbone to work across AESIN, one of the backbones is the relationship that we've got with first of all, AESIN's relationship with the automotive market, the automotive network, and the Auto Council, and bring that together with the infrastructure, the roadside infrastructure that the vehicles, the automotive vehicles are using, and the local authorities through ITS UK. And then on the local authority network through TTF, and across those three organisations, we have a relationship, and we meet on a regular basis. And with that too, we have relationships too with the operators, and in the group we've got the National Highways, who operate the strategic road network, and we're going to hear from Max Ash a bit later on in this call about the work that's going on in that area. And we've been bringing this group together in the interests of this group through a series of workshops and webinars. And probably 18 months ago, a bit longer than that, we had a Clash of Systems workshop, which really looked at the systems issues of the automotive as it integrates into infrastructure. We then, last July, we had a Bridging the Gap webinar, and that was really more focused around integrating with the infrastructure. And then today we're looking at things more from a systems and a resilience aspect. The same issues, but just looking at it from different perspectives. And we're trying to bring all that together to get to a national vision and blueprint, where we can try and align the industry, everyone who's in the call today, operators, academia, and government. And we think once we get to that point, we've got getting something that we're all looking at it the same way. We're all moving, hopefully, forward in the same direction, and we get some momentum going across this market area. So that's briefly where we are at the moment in the System SIG. So back to you, Pete. Thanks.
Thanks, Richard. And just to say that within that members plenary, there was a number of other topics that came up. This is the reason why we're talking about resilience, is that was something that people want to talk about and do a bit of a deeper dive on, which is the purpose of this workshop. But there are others, and there will be other things coming later on in the year from that from what the members want to discuss. So let me go talk next and just give a very high level view of resilience from a systems perspective. A little bit about me, if you don't know who I am. I've spent most of my life working electronic systems, from aerospace to road infrastructure to even some bizarre things in TV and broadcasting. So the role of a systems engineer, if you're not aware, is to engineer the system and to make sure that the system that has been designed meets the requirements of the stakeholders, and go through a process of rigorous and robust validation and verification to prove that the thing that's been designed is the right thing and has been built right, using that well-known definition of V&V. So that's my background, working for companies like Rolls-Royce and BA and Siemens. So apologies about this slide. I don't like the colour scheme, but it's a template. But I thought I wanted to show what a complex mobility system would look like. And this is essentially just showing that as a mobility system operator in the centre of a bunch of constituent subsystems supplying enterprise journeys, vehicles, test and assurance framework, content provision, etc. And these are all working in consort to give supplying journey to a mobility user. So, not a particularly realistic view of a mobility system, but it does show that the system is made up of lots of little separate subsystems or constituent systems that all have to work together to actually derive and produce the set of attributes that we want. So, I'll put over here some of the things that I think we want. We want it to be safe, secure, fault tolerant, affordable, and from my perspective, I want it to be sustainable. And I think some of these attributes can only be delivered if all the systems actually work in concert to deliver those attributes. And that's a very interesting point, I think. And I've highlighted some of here what some of the attributes would be to actually give some form of resilience to it. So self-repairing, self-organizing, autoimmune, provable, verifiable, and even provable. Going into the world of formal methods and things. So there's a true center of a trust anchor in the actual system architecture. So anyway, the point really is that there's lots of constituent systems, and every system itself is normally described as a part of a complex system or system systems. So we've been talking about this for a long time. Me and Paul have been realising for a very long time that we need to think about the automotive electronics system as part of a larger system, and as I say, we need to actually have that viewpoint in our mind when we design these systems. I don't know if people are aware of this particular taxonomy. It's a way of actually talking about complex systems. So the system I showed on the previous slide was what we call a directed system of systems. So there's a central management unit in there, or central management control, who's directing all the subsystems to deliver that output to the end user. The end user is not part of the system because you can't engineer the user themselves, despite what people would like to do. But that is essentially our directed system. But if as the level of control sort of evaporates and dissipates, the systems go from a sense of being directed to there's some sort of overall agreed, acknowledged joint purpose for these systems, to the point where actually the system is a bit more collaboratory, voluntary sort of interaction, then to where a lot of systems are within transport. They are virtual. The systems are absolutely, well, not absolutely siloed, but the point of interaction, I think our good friend Andy Graham always says, the point between the automated system and the infrastructure is where the 4 bits of rubber hit the tarmac, and we don't want to be there, because some of the higher level systems attributes you want come from operating as a more directed, more acknowledged systems. But as I say, most of the system systems are really a combination of they're not. This is just a way of actually understanding them. And one of the big points I want to really make is that the systems can only be considered as being truly independent if they're not interdependent. And unfortunately, a lot of the properties you want to engineer from the system come about because there is an independence. It may not be recognised, it may not be acknowledged, but unfortunately, that is the purpose. And when we come down to resilience, the interdependence of these constituent systems is of vital importance. It's vital. So next one. I'll just do this very, very quickly, because there's a lot of terminologies here that people use, and sometimes we definitely find these words are overloaded, and people have different understanding of what they actually mean. So when we talk about resilience, from a lot of this terminology comes from biological systems. So a resilience is the system's capacity to return to equilibrium after some disturbance. The robustness of the system is the extent to which the system functions are deteriorated. In our particular case, we are very concerned that any safety critical systems operate during disturbance, whether that disturbance is a cyber attack or a AI misinformation attack or something like that. And then rapidity recovery, I think it's fairly obvious here, is that it's at the time it comes back to a level of operations before disruption. So these are generally just some of the terms. There's quite a good reference here from the OECD about transport system resilience, talking about a larger sort of multimodal system viewpoint. And this all comes down to a sense of risk. If you understand your risk, that's where you actually try and deal with it. If your system is never going to be attacked by a external disturbance, okay, you're okay. But if there is something that you're concerned about, and particularly if there's a specific use case that you're trying to protect, that's where you really need to consider the system's resilience. I mean, I would say that a lot of security models in the past tend to be somewhat brittle. We have a hard shell of security controls, but once you're inside, then that's an issue. So that's more of a static system, where resilience talks more about dynamic systems of operation. And for us, the causes of disruption are varied. I mentioned cyber attacks as being one, something that our industry in automotive have put a lot of work over the last number of years, 5, 6, 7 years, to actually engineer into our systems. But other attacks are attacks which are somewhat more accidental. I mentioned AI information because that's come up as a high risk on the latest World Economic Forum risk report, and something that I'm not sure we're actually prepared for. But strikes, operational failure, etc., all these things can cause a system to be disruptive, and then we would like to make sure that we've engineered some form of resilience and recovery into the actual system itself. So system challenges, right? This is where we just start thinking about what we want to what we should worry about when we're designing these systems. I think the first one is making sure that we identify the system of concern, or the system under investigation, and that's quite difficult. The first slide I showed was my simple interpretation of a mobility system, but there are other ways of looking at it. I have a far more complicated, elaborated view of the systems architecture for that, which we can talk about at a later meeting. We need to identify the appropriate use cases that we are concerned about. What do we want to make sure is protected by our resilience controls? I mentioned the point about independence and interdependence. Then how do you manage the risk? Risk management is very interesting. Something's on the risk register because for an organisation, because it could affect its bottom line. So it's about how can you actually interpret resilience into something that a business or an organisation concerns about. Who actually owns the system, and who's actually in control of it, as I showed from that simple systems taxonomy point. What is resilience? How do we measure it? How do we maintain it? How do we implement it? What controls do we put in there? And also, how do we manage the system as the technologies that are being introduced cause new potential disruptions? So we mentioned EV, Paul mentioned EV, and I've mentioned the potential of AI disruptions. So this is another well-known curve, a bit more detail about what resilience is, but the same idea. It's operating, it gets attacked, it recovers, and then returns to equilibrium, or maybe not in this particular case. So that is all I wanted to say about resilience. I'm not sure if there are any questions, but we could probably answer them in the workshop. The next section is I think to do the first workshop, which we'll want to talk about use cases in particular from your perspective. Get an understanding. What are the use cases that you're concerned about, that you believe need some measure of resilience to achieve your business aims or the system's aims? Does that make any sense? I'm sure I was talking very, very quickly, because I always do. There's a question. Okay. So, Gunny, I think that the next point is that we're going to split into some work groups. Is that correct? And I think what we were doing there, we've got a bit more time. We can talk a little bit about who we are and share some information about who we are and our affiliations.
Yeah.
Right?
Okay. Thanks, Pete. Yeah. Okay. So thanks for setting the scene. I think this is great. It shows how complex the topic we're dealing with, and it's great that we have such a cross section of stakeholders in this whole space. So we're going to assign. We've got 3 breakout rooms. I've assigned you randomly into those rooms. I will open the rooms in a second. So we've got 3 facilitators in the room. So in one of the rooms, Pete will be there as a facilitator, and the second one, Richard Scofield, will be facilitating, and the third one will be Paul Wooderson. So the idea here is to talk about use cases. So as I said, a diverse cross-section of stakeholders. So please share your views of use cases that are relevant for this whole world of connectivity and the fact that resilience is going to be an important factor, and talk about the challenges or the concerns you have. Pete, Paul, and Richard will capture some notes, and after about 20 to 22 minutes, we'll close the rooms, we'll call everyone back, and we'll ask them, Pete and Paul and Richard, just to summarize maybe 3 or 4 key points or key use cases that arose that could be topics of interest for us to pick up in future conversations. Okay? Okay. I think we're all back. Okay, Pete, shall we just go around the rooms? Yeah. Okay.
The first question, I wasn't sure whether the recording worked in the breakout room, so I ended up taking lots of notes. And first thing I'd say is thanks to everybody. It was a hose pipe of information coming through from the various domains, and I think it's quite difficult to summarise, but there was a general view that there is an awful lot of work currently going on with resilience and resilience standardisation, but it hasn't been sort of as well communicated to the overall community. A lot of the work is coming from cybersecurity, whereas a lot of the impacts on the system, especially when you're using V2X data as part of your sensor suite, is that the attacks or disturbances to that data are not from cybersecurity, but could be from any technical failing or operator failure. So this needs to be incorporated into the overall thinking. That we all felt AI data or AI information, misinformation, disinformation is a potential future disturbance. We're not quite sure how to deal with it, but the overall robustness controls and managing data sensitivity is all part of that question. I think people within the automated cyber world felt that they are trying to deal with a lot of issues, and a lot of the issues they're trying to deal with are outside their domain of control, coming from the other constituent systems, and we got a number of use cases from real-time network management, but the other point there was that the road network is quite it's a variable, and the actual vehicle fleet on it is very disparate, from old vehicles to new vehicles. We know that the vehicle life cycle is around about 8 years. So how do you deal with that? And then there's also a lot of discussion about or some discussion about resilience as when it comes up to V to G systems, and that we need to appreciate the vehicle as part of the wider energy infrastructure, and it's not just a sink of charge, it's also a source of charge that we need to have managed. But the other point was that we do feel there's not a consistent language across the group. There are the standards that are there are not well communicated and not appropriate to all parts of the larger system of systems. So I think I'm going to stop there, because I'm still trying to process all this amazing information that the guys gave me. Thank you very much to everyone.
Brilliant, Pete. Thanks very much. It's really interesting. Richard, I'm going to head over to your group.
Yeah, thanks, Gunny. Thanks, Pete. So our group was probably more of had its roots relating to infrastructure than anything. But actually, what I found very interesting was that the local authority infrastructure, and we had strategic road network, motorway network infrastructure. Both quite an early stage of development, and I think on the motorway side of it all, still trying to work out, understand what the infrastructure may look like now and into the future. Could see that the requirements are complex, but still trying to sort out the needs, I guess, in that particular area. The local authority area, the local roads network, bit different there. There's quite a bit of work was discussed around the charging networks and the complexity of that. And whilst there's work taking place in deploying the charging networks, that the understanding of the wider system issues is quite immature, particularly in the areas of cyber and cybersecurity and those sort of areas. And there's definitely work to be done, I guess, in terms of what was coming out in the requirements that need to be addressed, and the understanding from the client who actually is procuring those and deploying those, and the type of contracts that they're and the length of contracts that they're being deployed through. Also, that took us into an adjacencies in terms of other sectors, and what was raised through the payment systems, that the payment systems that may be involved in the charging networks are also being used in other sectors such as healthcare and the health sector as well. So there was another perspective brought to it all there. And we also come back to where I just started there, which is these are all complex systems, and we're developing and migrating, whether in the autonomous vehicle side, the infrastructure side, the charging network side, developing rapidly in systems, probably with industries and parties that haven't had to work to date of systems with such complexity, and manage the issues that go with those. That's our group. Thanks for that. Thank you.
Richard, thank you. Brilliant. Yeah. I think complexity keeps popping up. Okay, brilliant. Thank you, Paul.
Yeah. Okay. We also had a great discussion and lots of use cases. So I've got some notes, and I'll just try and summarise some of what we came out with. We had a few use cases which I'll go through first, and then some sort of challenges or needs that apply to some or all of those use cases. So some of our use cases were things like road operators being able to monitor and understand their road network and the maintenance of the road network. So from a sort of operational perspective, we had safety related use cases, things like reducing insurance costs and other costs to road users, and improving safety of connected mobility. We identified some very specific use cases, like maybe road pricing. Will the government want to move to sort of road pricing or price per mile type use cases? We touched on the EV charging infrastructure, and that infrastructure, particularly when it's used for charging sort of commercial or public service EVs, becoming part of critical national infrastructure. We talked about APIs or interfaces between different stakeholders in a connected mobility system, things like the extended vehicle standards, and what happens over time, over long lifetimes. Maybe these APIs become obsolete or become changed. How do we phase these things in and out over time? Some of the challenges were identified were around, particularly regarding the sort of road networks, road operators type use cases. The system of systems is currently incomplete. We have different road types with different types of communications infrastructure, some of them with no communications. A lot of the use cases, if we're going to implement them, we need some kind of timeline around them to making them happen. We also touched on the complexity challenge, including things like how these systems impact things like write-off of vehicles in accidents, how resilience can impact on sustainability in a positive way, and the reuse and recycling of components, particularly of vehicles we were discussing. How can we sort of recycle increasingly expensive, complex components of vehicles? What did we look at? The challenge of managing technical artifacts, things like cryptographic keys over long life cycles, and one that we got right at the beginning actually was ensuring that whatever these use cases are that we're implementing, not losing sight of the relevance to the user or the consumer. Is it something that the user actually needs, to not lose sight of that. So hopefully my compression hasn't lost any information that was given in the session, but that was our group's summary.
Well, thanks very much. Yeah, very, very interesting and very diverse. We had a small splinter group of participants who couldn't join the breakout rooms, so we had our own little sessions. I just wanted to take a couple of minutes because it was interesting, the use cases that were coming up. A lot of it from vehicle side, which I thought was an interesting insight to understand how the vehicle side sees the world. So for sure, software-defined vehicle and the shift of the way the vehicle is going to be architected is a thing that was mentioned, and especially the over-the-air aspect of communication and what OEMs would like to happen with that link. And some of the challenges around that actually around it's almost organizational, because a lot of OEMs a lot of OEMs want to bring development in-house and make and develop vertical organizations. However, they don't have the capability or the maturity to do that, and so there's this reluctance to rely on where the knowledge lies. And when you talk about connectivity in the cloud, it's very much to do with the IT world and the companies in that space there. So we talk about Google, Amazon Web Server, and AWS and others as well. But there's this reluctance to go and do something around that. And equally with standards, as this whole space evolves, there's a lack of standards or too many standards sometimes to know which ones to back. So I thought that was really interesting. There was the EV charging infrastructure and the CPO point of view was raised, especially around not the fact that they haven't got connectivity, but the fact that they're in such a rush to get technology deployed or the charging infrastructure deployed, that these elements of resilience and robustness are not well designed in. They're not thought of until things go wrong. And they find challenges now. There are challenges with this, not only with the payment infrastructure, but also when you start to move towards the use of data for enhanced features and functions, and how that's going to be impacted by the potentially lack of resilient systems. We had a view on perception sensors, so sensing for autonomous functions. And there are many use cases. Again, use cases mentioned for airside autonomy, port side autonomy, which is interesting because they're more constrained environments. But sensors themselves need to be resilient to the environment, to reflect your mutual interference. So, signals from other sensors that interfere with the operation of sensors, inclement weather, signal security, so jamming and spoofing, which I think would apply to any connected system, and even non-adversarial or just functional noise, things like oncoming headlights, for example, pose a threat to robustness and resilience, and having to manage that because you're now in a safety critical world. One other aspect that was that I mentioned is talking about on-chip resilience. Actually, as systems evolved and there's a need for robustness and resilience, there is more and more design of redundancy on systems, especially down at the chip level. And that puts an overhead both on the cost of design, cost of component, and the cost of testing. So there's this knock-on impact in trying to address resilience and robustness through component design that actually starts to impact the whole system cost. The final point here, and I thought this is a really key point, is that point was made that we have to change the way we look at cars. They're actually now a node in a system of systems. They're no longer the system itself. They're actually part of a system, and there's a fundamental shift in the way we need to look at them. Okay, those are 3 or 4 Pete from my side. Back to you. Thank you. Thanks to everybody.
Okay, brilliant. That was, again, we obviously have hit a big whole font of information in this area. So I think we're going to spend a bit of time to digest all this. But I do think we got enough here for a full-on conference. So the next thing we wanted to talk about was we're going to queue up Paul, who's going to talk about automotive systems. Shall I just cue the slides, or do you want to share it from your machine, Paul? Am I sharing at the moment? Don't think I am. I mean, that's silly.
Sorry, I was on mute. I don't mind if you want to share them, and then we can follow on afterwards, can't we then?
Yeah, so you just call out, please, next one.
Yeah. Okay. So yeah, just a few minutes to sort of give an overview of what the sort of automotive or vehicle angle on resilience and systems resilience is, and just sort of starting from the perspective of the connected vehicle as a sort of cyber physical system, and how we sort of see the move now from computer security as it's applied to cyber physical systems, moving very much from a confidentiality problem, which a lot of computer security has been sort of until now, but now we're starting to talk about cyber physical systems where the elements we have in vehicles, potentially their failure or attacks on them can potentially lead to loss of life, and the need for ensuring the resilience of these systems points as much more to the other two properties in this security property triad of integrity and availability, which are much more important to us when we're thinking about resilience and keeping systems operational and performing as they're supposed to. So could we move to the next slide, please, Pete? So the kind of the classic example that we always talk about with automotive cybersecurity is, of course, the famous Jeep hack, the research published quite a few years ago now, nearly 10 years ago, when these researchers discovered this and published this remote cyber attack on a vehicle that had some demonstrable safety related effects, so they could control the steering and braking of this vehicle through a remotely initiated attack. And that's what's very much led to the need for cybersecurity and cyber resilience in the automotive sector, this kind of safety angle. So if we could move on again. Yeah, so as this sort of need has become apparent in the automotive sector, we now have a very regulated space with the arrival of Regulation 155 as part of the, it's just one of many regulations that need to be met for vehicle type approval in the global markets that have vehicle type approval. So we now have cybersecurity as a regulated area. We have standards that have been published for a few years, like ISO SAE 21434, and we have more on the way. So those ones at the bottom there in yellow are currently under development, sort of providing guidance to the automotive industry on cybersecurity and on software updates and related things. And not only that, we also have other regions introducing regulations. So we now have vehicle cybersecurity regulations from China, and we also have the EU Cyber Resilience Act, at least in the EU, which is affecting not so much the vehicles that are already regulated under Reg 155, but other adjacent types of products. So other sectors maybe adjacent to the vehicle sector, maybe some off-highway sectors are falling under the Cyber Resilience Act in the EU. So we have a lot of regulations and standards emerging, and it was interesting to hear some of the inputs in the workshop were about the sort of proliferation of standards and regulations and the need to be able to cut through all these different requirements. So could I go to the next slide, please? So with the regulations now in place, the automotive industry's sort of now addressing a number of challenges. So we've got these regulations, we've got standards, but some of the questions now were around now that we've gone through applying those maybe to 1 or 2 initial vehicles, how does this scale up? How do we do the activities we need to do at scale so that they continue to sort of add value and improve resilience, and don't just become a sort of tick box compliance activity that where we lose the value and just create everybody a lot of work without getting the value out of it. So how do we keep that addressing security and managing risk and not just compliance? And then sort of more technical challenges around how do we move from a sort of unsustainable sort of patch management mode where we're just chasing vulnerabilities and patching them to a more sustainable approach where we know how to properly detect, understand, and resolve and respond to the evolving threat, and the resilience piece really falls into this. How do we improve our detection and response to attacks to the point where we can meet some of these resilience properties that Pete outlined earlier. And then the third piece of this is what threats and also opportunities do emerging technologies like electrification, EV charging, etc., AI, what do these bring in terms of threats, and how do we deal with those, particularly thinking of the wider systems that the vehicle's connecting into. Let's go to the next slide, please. Yeah, so the sort of wider system approach, we've touched on this a few times already. You know, so we've typically thought of the vehicle as itself a kind of system of systems where we've got multiple components, both hardware and software, from many different suppliers, all somehow being integrated into a vehicle, and all the things that can go wrong as part of that system. But of course now, as Pete outlined earlier, we've got vehicles becoming part of themselves part of a bigger system of systems, where we don't have a single party responsible for the overall security. We don't even have the ability for different participants in these systems to make contracts with each other necessarily and pass on requirements. So who's in charge? Who's directing the overall security and resilience of these systems? These are some of the challenges we have. Go to the next slide. So yeah, the example of this, and this came up in some of the group sessions just now, is the sort of EV charging system of systems, where we have vehicles connecting to charging infrastructure, and then the charging infrastructure itself is connected to a number of systems to manage sort of the provision of the power and the payment services behind them. And at all of these points, of course, we've got opportunities for cyber attacks. We've had number of attacks demonstrated at the sort of connection between the vehicle and the charging infrastructure, and beyond that. And we've got a number of sort of types of threat there, both to the safety of the vehicle and its users, through to sort of financial type threats and operational threats in terms of the sort of the critical infrastructure aspects of sort of large scale EV charging facilities, for example. So we go on to the next one. And then thinking again about the sort of resilience and how do we improve our detection and response. So the regulations that I mentioned earlier have specific requirements in them for vehicle manufacturers to have both processes and also technical measures in place to be able to detect emerging threats and vulnerabilities in their vehicles, and to be able to analyze those and respond appropriately. So these are quite hard requirements in the vehicle regulations, and there's a need to basically work out what do we need to do that effectively. Is it on the vehicle? Is it off the vehicle? Is it a bit of both? And how do we do it in a time frame that's helpful? So if we could go one more slide on, please. It's the last slide. So there's some questions to answer, particularly when we're thinking of the vehicle in the context of a resilient system. How do we do this monitoring and detection? What do attacks on vehicles and on the systems they connect to look like? How are we going to detect them? Do they look like typical attacks that we have a lot of data about from maybe the IT world, or maybe they're a bit different? How do we understand what it is we're detecting so that we can make decisions? And what's the right kind of response? Do we need the ability to respond and hopefully recover in real time so that we can maintain the availability of the vehicle? So thinking of connected automated mobility, these kind of availability and recovery times are going to become quite critical. And if we have all these processes and measures, we kind of hope we don't have to use them. But how do we validate that they will work for us when we do need to use them? How do we measure how good our detection and response and our resilience measures actually are? So I guess these are some of the open questions to address, and some of the challenges we've got from the automotive focus. So I think I'll leave it there in the interest of time.
Fantastic. Thank you. So we're now going to hand over to Max. Ooh, sorry, I just. So, hi Max. This is your bit. Should we do the same and I'll click through?
Yep, I'll just say next slide or whatever. So hi everyone. Some of you will have seen aspects of this presentation before. I think I gave a similar one back in June, July at the start of this, the Bridging the Gap workshop. But I work at National Highways in our Cyber Futures team. So Cyber Futures was set up to kind of understand how technology changes will affect security and resilience at National Highways. We've got strategies like Connecting the Country as an organisation, and that looks forward to how National Highways will operate. I think it's in 2040, it might be 2045. And there are a lot of changes and a lot of kind of new technologies that we're expecting to be used. And so kind of understanding how security and resilience will kind of change as we move forwards is kind of a really, really important thing. So next slide, please. So one aspect of this, and I guess particularly relevant to this group, is the kind of increasing kind of evolving need to see the highways as part of a complex system. There's already a lot of technology, in use at the moment. Things like stop vehicle detection, use radar by the side of the road, roadside sensors, things like MIDAS, variable speed limits, obviously, and things like smart motorways. But there's also those kind of emerging technologies that will affect the road operator. So things like connected autonomous plant being used in construction and maintenance. So as kind of roads are being maintained, making use of kind of smart autonomous vehicles that make that more efficient. Things like increasing use of IoT sensors. So particularly again in the construction side, but also in the traffic management side, kind of the cheaper kind of internet connected, widely deployed, widely used, potentially heterogeneous networks of kind of sensors that might affect things. Increasing use of third-party data, new methods of connectivity. So things like 5G being added in, updates to NERTs, things like that. But also things like National Highways becoming a data supplier, so supplying to customers via businesses, via methods like Digital for Customer, which is the kind of ongoing program. But then there's also things that are kind of operating on National Highways infrastructure that are directly or not directly in the control of National Highways, and this is where that kind of complex system thing starts to evolve. So we're going to see things like connected autonomous vehicles. Obviously, we've been talking about that today. Increased connectivity, so the 5G thing. Other road authorities also becoming more connected in the same kind of ecosystem. National Highways is only a small part of that, a small part of the picture. And yeah, similarly, like Paul mentioned, the increase in the use of EVs means increasing reliance on charging infrastructure. And there's kind of direct impact there with things like traffic officers and the need to kind of keep them running. But also there's the kind of onward impact of the failure of that infrastructure if public charging infrastructure fails. If people can't charge at service stations, what does that mean for the motorways? What does security issues around those things mean for the road system? So yeah, all of these things together mean kind of a more complex system changing threats, changing exposure to threats, which means kind of changing security and resilience responsibilities for the road operator as kind of that part of the system. So next slide, please, Pete. Oh, it's got some animation on it. So yeah, as part of this work, we've considered like a wide variety of security scenarios from a kind of now, next, later viewpoint, across kind of a range of technologies. This is some of the Cyber Futures views on how things will change and affect security and resilience out to 2040 for the connected autonomous vehicle use cases. So we see, and the kind of strategies predict kind of a reduction in road signs, you know, eventual move to this kind of idea of the naked motorway, where data is directly delivered to vehicles to kind of enable them to understand what's happening on the roads. And that kind of introduces the need for this data exchange to be trusted and relied upon. You need to be sure that you've got the connectivity. You need to be sure that the data that's coming in has not been kind of edited, that it's correct. As actually Malcolm mentioned earlier, an increasing number of autonomous vehicles being used, but there's a need for them to cooperate. So as we kind of end up with some people having connected vehicles, some autonomous vehicles, some kind of standard vehicles, how do they kind of all work together? And so the security and resilience on the vehicle starts to matter then. And possibly, you know, at least some cooperative infrastructure for some more complex aspects of the road network. So, you know, the need for autonomous vehicles to have enabled corridors, for example, for some kind of more complex things like slip roads and more complex junctions. And a kind of key one for national highways, and something that we've kind of seen coming up a lot, is that all of these things mean there's it increases the extent that safety becomes reliant on security. So or they become kind of converged. So more technology integration means more physical aspects if things go wrong from a security point of view, and that starts to really matter. So next slide, please. So these are some of the security threats that we see kind of emerging based on that view forward. What does ITS, CAV, etc. mean for us? These things all affect the road network, but a key point is that many of them are kind of outside of national highways control. Some of these things are fairly low complexity. So, you know, GNSS jamming is probably possible with things you can buy on AliExpress. It's, you know, it's not crazy to think that. But we've also got things like alteration of physical infrastructure, adversarial AI attacks, you know, making changes to road signs to impact the systems that are picking things up on kind of vehicles, kind of leading to image recognition, not classifying things correctly, things like that being a problem on the kind of low complexity side. Then we've got things that are kind of outside of national highways control, so attacks on vehicles or charging infrastructure, but they could have larger impacts on the road networks. So effects on kind of how transportation works. And then some of them are kind of broader and kind of might affect the whole system as a whole. You know, we see it in the software space. Things like, you know, Log4j a couple of years ago had wide-ranging impacts across a wide range of systems. Everyone kind of panicked to fix it. But things like the increase in IoT use or the kind of increase in software and vehicles, you know, makes that wider across the entire system. So yeah, so to kind of ensure resilience, I think the key message here is that we need to kind of approach things together. So next slide, please. So these are some of the kind of key activities that we've been carrying out as Cyber Futures over the kind of last year to try and address some of these problems. So a key one, like I mentioned, is the safety and security convergence. So we've been kind of building together a safety and security working group, community of interest, community of practice, that's the one, to try and work out exactly how we can kind of align things, you know, even at kind of basic levels, things like, do the words mean the same things? So there's a real issue with having a joint vocabulary that means that security and resilience, security can talk to safety and can kind of improve resilience together. But also the awareness thing, you know, making sure that people understand how security impacts safety is a big problem. And then kind of on the kind of slightly more lower technical level, how can you integrate security and safety processes better together, so that people kind of understand, or that when you're doing a safety risk assessment, you kind of understand how to pull those safety aspects through to make sure it influences the safety side of things, and vice versa. Part of that kind of awareness thing has been immersive exercising. But it's also been useful for the kind of resilience planning side of things. So we develop these immersive situations where security impacts operations, and it kind of allows the testing of how responses would happen in reality, raises awareness of issues, and eventually we kind of see it tying in with this modeling capabilities side of things. I think this is somewhere where it'd be really interesting to get the vehicle manufacturer's view of things as well. Like how does that compare with how the road operators are seeing things? How does a security incident on a vehicle manufacturer's side tie into the kind of response capabilities of kind of the road operator, and again, I guess vice versa as well. So what happens when in an autonomous vehicle situation the road signs fail or so on, and how does that kind of response capability go through? And then modeling capabilities, so trying to work out better and use systems to understand better how our systems interact. So we're trialing some software that helps us understand the interconnected nature of risk across the national highway systems. Does that expand out better to the kind of wider road network, to the wider system? So yeah, all of these things are kind of helping us to improve our response capabilities in kind of a increasingly complicated system, and kind of understand how the risks are changing as it kind of evolves. Just as a final one, next slide, Pete. I think this one might have popped up already today, or I was told it would. I actually don't think I spotted it. So this is a slide from the previous AESIN workshop that kind of sets out how this group is going to be working. And I think there's a really important point here that the interconnected systems mean that there's a wide variety of groups that need to work together to solve these problems. So the AESIN group, the ITS group, and the TTF and National Highways kind of fit together well to kind of solve these problems. I think it's increasingly tricky to tackle them as single organizations or single parts of a system. So yeah, that's kind of me, my brief ramblings. Thank you.
So the plan now was to have another workshop. I just think we need to have a quick review of the timings. I think that's what Gunny's also thinking. We're running a lot over. So I was going to suggest we just do a 10-minute workshop on some of these questions. Yeah. Just capture that, and then.
Well, Pete, we could have an open round just to hear. I think it would be good for people to share thoughts. Yeah.
So the questions we've already talked about the questions, but the ones we thought were important from this perspective was about the management aspect. The who owns the resilience for the system of systems. So that's a discussion we can debate. And if someone in the meeting wants to put their hand up, that'd be great, and we can all go home. But we don't think there is someone who does that. And then we will be interested to know about the metrics of resilience. How do you actually measure those resilience within your organisation? And if you haven't got one, that's also really interesting, because we could say that something needs to be created. Because I say this so many times, but in life and in systems, you only get what you measure. And so, if you have your dashboard on your system, on your system you're managing, what are those key parameters that you're measuring? And then the final question, we're not taking them in particular order, was how do you design in resilience to the system of systems and the constituent systems to allow for future disruptions? We mentioned already, because I just think it's something that's just really dawned on me that this could be a really significant risk to the system, is AI misinformation and AI disinformation, which come through and filter through the system, causing perturbations and unexpected outputs. So there's some of the points. I don't know who wants to go first, but be brave. Casey's got a hand up. Hi, Katie.
Hi, sorry, I'm always learning. So I've always got my thinking cap on. One of the things I was thinking about while watching or reading all of this and listening to what everybody's saying is that I'm not sure if anybody's aware of the local authority energy plan that's recently been launched and supported by central government. Basically what it is a plan to have a more integrated energy infrastructure. So basically what you would have is you would have the grid talking to the local grid, which would be fed energy from renewables that are from communities, businesses that are basically feeding the energy back into the system. The distribution network operators, so your SSEN, UKPN, are now rebranding themselves as distribution system operators. You've had the launch of NESO, which was basically National Grid had set up an energy systems operator. The government bought it off them and are now managing it along with National Grid, which is basically your pylons, your power stations, power station feed. So the energy infrastructure across the UK is completely transforming, and all of it is going to be data managed. I am just getting into this realm because I'm always looking at all the different angles, and all of the data that's also being fed into it is stuff from charge points, because charge points feed into the meter, feed into the transformers data management system. And so it's a whole integrated system. Now, from an energy perspective, I have no idea how secure our energy infrastructure from a data perspective is. So it's one thing I'm going to have to do a bit of research on, but it would not surprise me if there's insufficient security. Now, seeing as, and I'm going to go for it, both Iran and Russia have done state-funded hacks on hospitals, blood and transport, TFL, all sorts of things over the last couple of years. If it's not as secure as we think it is, how long is it going to be before our entire energy infrastructure is also hacked? I know that there's work being done, but it all links together.
Absolutely. I mean, the one of the things I mentioned in our breakout was that you should consider the vehicle, when the vehicle is considered as part of the smart grid. So it's just distributing charge around that network. And I used to work in energy security, cybersecurity, no surprise there. And it currently has that property of brittleness. So the actual the external is once you're, it's hard to attack the system, but once you're in, because you've got such a broad range of supplies to all the operators, etc. There's quite a lot of common passwords between various suppliers across that network. So, but then when we actually look at that, the external threat to the energy network, so it's a question of resilience and your risk interpretation. At the moment, the risk is quite low, we believe. Well, that's going back a few years when I was heavily involved in it. So is it balancing that risk and the amount of security and resilience controls? But yeah, we need resilient energy infrastructure because that impacts onto Max's road network, which impacts on Paul's vehicles and impacts on the ability of people to get around. So is that dependency network that we're trying to protect. So yeah, great point, really good.
If anybody's interested, I was talking to the workshop, but the group that I was in, but I'm actually head of the cybersecurity working group for the REA. We're in the process of pulling a document together that is advisory on just the basics of what the CPOs and local authorities need to implement to increase their security of data. There's going to be probably 2 or 3 follow-ups, which will then incorporate energy and also the distribution sector. it would be really interesting if anybody's interested in discussing this briefing with me. We'd love to hear your thoughts and input, because the group is small, but I'd really like to see, people that understand this in this group. It's not pitching, it's just if you're interested. I'll put my email in the chat, but yeah, it'd be really good. Thank you.
Brilliant. Rich?
Yeah, just pick up on Katie's point there. That great, that offer, and we'd love to continue that thread and that discussion point. Going back to a slide that was in Max's presentation at the start too. This forum that we have too through AESIN is with ITS UK and TTF. There's a thread there through TTF into the local authority network, the local authorities and the industry in that sector as well. So it'd be great to have you in that thread working into that one as well. And equally from the thread that we have within AESIN that takes us back into the industry and the Automotive Council as well. There's sort of two interesting threads that come with that too.
No worries.
Cool. So any other comments on these workshop points? I mean, I do like the first one. I mean, we've already just. Are people happy that our thesis that the complex system that creates the mobility infrastructure in the UK is a virtual system of systems? There is no overall control. And the features that we're trying to look for, such as resilience, security, sustainability, are purely just a happenstance of the system itself, or do we think it's more of a collaborative, acknowledged system? Well, Gunny's agreeing with me. Okay. Well, I'll try and answer my own question there. I do think it's a bit of everything. I think some parts are very well controlled. I think some parts are purely by happenstance, and I think that some of the important things that we need to do is agree on what things that we really need to control, because that helps reduce the system complexity. And for me, an affordable, sustainable, secure, and resilient infrastructure is something that I think we could agree on as properties, and then we can actually then architect the system to achieve that. There's a thing about system architectures. You think, well, there's already an architecture there, but it doesn't really matter. You'd have multiple overlapping architectures purely there just to deliver a specific subset of use cases. So we can talk about that as in a future meeting. So, anybody want to help me out? Ask a question, or are we just pretty well completely bamboozled by the complexity and the one thing I think is that it's such an important subject, and the breadth of it is it's a huge breadth, and to understand it requires a huge depth, a huge knowledge of each of the constituent systems. And so this is where this forum really helps, where you do have experts who are deep in the various constituent systems coming together. But it does take time for people to actually understand the language and eventually move towards a common data dictionary or an object type library, whatever is required then to integrate together. Thomas has put his hand up. Thank you, Thomas.
Just one little nugget to share is that I do find it something I've come up in the past is that having things treated in different silos, I mean, is always problematic, but in particular when it comes down to safety. So I do think it is important that everything that relates to safety in effect needs to have like one owner. And so, for example, cybersecurity outcomes that affect safety, they then need to be fed into a safety management system that then makes the decision as to what's best for safety. If it's treated under different silos, then that's problematic. You can have cybersecurity and safety fighting against each other.
That's absolutely correct. Yeah, I mean that's where we sort of the important thing is to understand the interdependence and independence of those two systems. If they are interdependent, you need to manage them. Sort of Christian's got his hand up.
Yeah, just what I want to add to this is that it gets really super complex, because even if you just consider cybersecurity and safety, if you take it away from just the pure vehicle, like in the overall system, I mean, we see it in the car industry already, how difficult it is to get cyber security and safety together just with one OEM and the suppliers. It's I don't know who would be the owner of the safety process, for example, of overall thing. If it just takes this attribute safety, I just don't know where to start really. And think this shows the complexity of the problem. That holistic safety in the car industry is already like an early one, where people think holistically between different safety aspects, even within one OEM, and on this lower level of maturity, expanding this to a wider safety. It's just really tough, and I don't know who would have the ownership really. I think that's one big question that always comes again, the ownership question, and who's leading the activities.
Yeah, it's a really hard question. It's for the person normally that experiences the pain of the system disruption, and so that they're the ones who are motivated to actually take control of the system. If it's self-insured by government, then it's it dissipates over the user base, and that's not. I don't think that's sufficient for actually to achieve the aims that we want. Daniel put in a question. It's basically, he said in CNI there is the resilience cycle. Is there any chance you can expand on that before we wash up? Sorry to put you on the spot there, Daniel.
Yeah, I mean the topic of resilience. If you look at the history of it, it goes back decades. I mean, even to the times of the Roman Empire, when they put systems into place to manage their armies, which made their armies so successful. So you can think of it, resilience as an engineering challenge.
Yes.
And then you need to think about, in that sense, what are the factors that make up resilience in terms of a system. So you can think of factors such as reliability, flexibility, adaptability, configurability. All these factors can be bundled under the resilience banner. And if you have these various factors, then you can start thinking about what metrics can we put onto these factors. How do we measure these individual factors within a system? And it is quite a challenge, because these factors aren't really directly related to the function of the system. We design systems to achieve a function, and so we know how many nuts and bolts, how many watts we need, how many resistors and capacitors. We have all these components that we put together to build a system in terms of engineering, but it's these other factors that make up things like security, safety, reliability, resilience, that we don't measure. And it's how can we start thinking about measuring these non-functional factors and creating some sort of metric that we can apply to our designs. Can we build these non-functional factors into the tools that we're designing our systems with, and that they can produce metrics that we can act upon? So if we're trying to make a resilient system, these non-functional factors become part of the design itself.
Yeah.
Those sort of aspects we probably need to think about in terms of improving the resilient aspects of our designs.
I think there's let me just try and summarize. I think what we're trying to say, yes, measuring resilience, robustness, flexibility, vulnerability are all important things to define. They are defined in some domains, not so well in other domains. So in this particular complex system, where we're bringing people from different aspects of it, we need to have that common language, that common definition, and the common set of metrics. And some of the metrics for the road network authorities will be different from those of the automotive manufacturers, but in terms of the end user who we're designing the system to meet, they're the outcomes that we should try and seek and get those defined.
Yeah, I just take 30 seconds of everyone's time, because I think this is just to then let you know about future events. So there are two very relevant and important events. Share. Okay, there we go. Right. So there's an event on the 25th of February around TechWorks AI, which is one of our new networks, exploring all things AI and the impact of the AI is going to have on us. And I think it's very relevant to this group. So already we've got speakers from Amazon, BAE Systems, DCIT, and SAP speaking at the event. So you can take a screenshot. We'll send this out as well, but you can take a screenshot of this and you can jump on the QR code and register. So that's really important. That's at Bletchley Park, so it's an iconic venue for security, and of course the AESIN conference. So again, you're all invited. This is our flagship event on the 19th of June at the British Motor Museum. We are actually investigating whether we could have a sit-down dinner after the conference, so we can make it a real networking hotspot. And we're excited. We just got the schedule sorted out. We are now going to be putting out a call for speakers. This is a topic of particular interest, so we want to have one of our sessions around this as well. So we'll be keen to look for your support for this. But you're all invited. Again, take a screenshot. I will send this separately, and register yourselves already for the event. And aside from that, if you're not AESIN members, then you need to contact me to find out about membership. And we'll get you all the information, and we'll make sure that you're engaged in more of these activities and you get the benefits of being an AESIN member.
Well, it's only to say thank you very much for your participation, and thanks to our speakers. It was brilliant. I think there's a fire hose of information and data came through. So, and look forward to talking on this topic in the near future.
Thank you very much. Thanks to all.
Thanks
Have a
very
great
much.
day.
Bye, everybody.
Bye-bye.
Bye for now.
Thank you. Bye.
Cheers.
Bye.
Thanks.
Thanks. Bye.